Hello students, this is Anita Raj, your chemistry mentor, welcoming you back to one more session in haloalkanes and arenes. I think we shall straight away move on to the topic SN1 reactions in haloalkanes and arenes. So what do you mean by SN1 type? See, 1 in SN1, 1 represents unimolecular, N represents nucleophilic and ES represents substitution. So SN1 means unimolecular nucleophilic substitution reaction. Okay, so what do you mean by unimolecular? See, normally the rate of a reaction, that is specifically the nucleophilic substitution reactions, okay, nucleophilic substitution reaction depends upon the concentration of the substrate alone and not on the nucleophile. So what do you mean by a substrate and what do you mean by a nucleophile? So for that we should understand reactants are of two types. The first one is substrate, okay, it is a substrate. And the second one is the reagent. Okay, so what do you mean by a substrate? So substrates are the substances being attacked. They are the substances being attacked. Okay, and what do you mean by a reagent? Reagents are the substances which attacks. This attacks the substrate. Okay, this attacks. All right. So actually these reagents are of two types. Okay, one is electrophile and another one is nucleophile. Okay, nucleophile. Okay, now this, what do you mean by a nucleophile now? See, these nucleophiles are the electron rich. Okay, they are the electron rich species. That means this will be donating electron pairs. This electron rich species will be donating electron pairs, and these electron rich substances will be having a negative charge. It may have a negative charge or it may be a neutral one. Okay, if it is a negative charge, then examples are OH minus, okay, Cn minus, right? And then neutral means water. Water is an example or neutral nucleophile. Understood, students? Well, when we start learning this SN1 mechanism, you should always remember certain points and one trick. So let us say those points one by one. The first one is the strength of the nucleophile. See, even a weak nucleophile can help this SN1 type of reactions. And this SN1 type of reactions are of two, they have two steps. So the first step is the rate determining step. Okay, the first step is the rate determining step. What do you mean by rate determining step? Mean the rate, that is the speed of the reaction is determined by the first step. It is a slow step. Okay, the first step is the slow step. Look into the next point, students. Tertiary alkyl halides undergo SN1 reaction fast. Yes, this tertiary alkyl halides, normally they will be undergoing this SN1 reaction fast when compared to the secondary alkyl halides and the primary alkyl halides. This I will explain when I am explaining the mechanism. Okay. Next one is the polar protic solvents. What do you mean by polar protic? See, polar protic means those are the solvents which can furnish H plus ions. Understood? See, these polar protic solvents, they can ionize easily and they can furnish this H plus ions to the reaction mechanism. Okay, so example for this polar protic solvents are water, alcohol or OH, then acetic acid. So these are the examples, few examples for polar protic solvents. Okay, this helps in SN1 mechanism. And the next one is, next point is, which you should remember is, see, this in SN1 type, inversion and retention of configurations of products is seen, right? They are obtained. Inversion and retention of configurations is obtained. When this also I can explain when you see the mechanism, right? And the next, it depends upon the stability of the carbocation. See, this SN1 type, as I told you, it is a two-step process. See, in the first step, there will be formation of a intermediate product. Okay, there will be a formation of intermediate product, and this intermediate product will be a carbocation. So, that is a carbon, it has a positive charge. So, cation means positive, an ion which possesses a positive charge. So, an intermediate will be formed which is a carbocation. Well, we shall see the mechanism of SN1 type, students. So as I told you earlier, this SN1 mechanism it's a two-step process. We shall see the first step. See, I am taking a tertiary alkyl halide. Now, this is a tertiary alkyl halide. See, X represents the halogens, and C, this is the tertiary carbon atom. See, this carbon atom is attached to 3 more groups. Okay, see, the functional group is attached to a tertiary carbon atom which is attached to 3 more groups. So, it is an example for tertiary alkyl halide. Okay, see the structure of this tertiary alkyl halide. This is having this is sp3 hybridization. Okay, the carbon here is in sp3 hybridized form, and it is having a tetrahedral structure. Okay, tetrahedral geometry. Okay, so now see, normally a normal nucleophile, say when you are taking into account OH minus, it's a nucleophile, is it not? This cannot easily attack this tertiary alkyl halide. Reason is, this tertiary alkyl halide, this carbon is having 3 more alkyl groups. These groups are bulkier groups. Okay, so here comes the steric hindrance. See, it is not easy. It's not easy for this nucleophile to come and attack this carbon atom. Okay, because 3 bulkier groups are there. So here we are making use of a protic solvent which can assist this SN1 type of reaction, that is step 1 reaction. This protic solvent, it will be furnishing H plus ions. Okay, so protic solvent, I am taking water as an example. So this water can furnish H plus ions. Since it is furnishing H plus ions, this chlorine atom, see if we are taking a halogen, this halogen is more electronegative when compared to this carbon. So what happens is, this halogen will be leaving this alkyl halide by taking away the electron pairs from the carbon, and it will join with this H plus. Understood, students? This will join with this H plus, and it will be removed as HCl. Now what happens? This carbon, after the removal of X, that is halogen, it will be gaining a positive charge. Okay, so this structure is called as the carbocation. Since it is gaining a positive charge after the removal of halogen, this is called as a carbocation, and this has the geometry, that is, it is sp2 hybridized now, and it has a geometry, that is a structure trigonal. Okay, trigonal planar. See here it is having only 3 attachments, right? CH3, 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 and no halogen. So it is sp2 hybridized, and it is having a trigonal planar. But here it is having 4 attachments, so it is sp3, so it is tetrahedral. Now we understood. See, this is the carbocation. Now the nucleophile can easily attack this carbocation, because the nucleophile is carrying a negative charge and this is having a positive charge, so it can easily attack. Understood? Fine. Look into the second step, students. See, here I have taken the carbocation now. This is the carbocation C plus CH3 CH3. Okay. Now see, the nucleophile is directly attacking. So, okay, in the second step, the nucleophile attacks the carbocation. See, there are 2 types of attack, that is a front attack. This is, see, the nucleophile is attacking the carbocation from the front side, and the nucleophile can attack the carbocation through the back side also. So, we shall see the front attack now. Okay, so this is the front attack. So, when this nucleophile is attacking the carbocation through the front side, we will have a structure like this. So, we will have the product. The product will be formed like this. OH will be in this position. Okay. So, if it attacks the back side, see, if this is the back attack, so backside attack will have a product like this. So, this is a backside attack product. See here, the OH molecule will be this OH molecule will be coming and attacking the carbocation this side, so that the product will be like this. The OH will be placed in this position. So, this is front attack, this is back attack product. Okay. Now, so during front attack, we'll have the retention product. Okay, this product, it is called as retention product. Okay, this is a retention product, and look at the hybridization now. It is sp3. See, we have got the same type of structure sp3, so it is tetrahedral and it will be 50%. Okay, 50% will be the retention product, and this is an inversion product. Okay, what do I mean by inversion? See, in the previous one, that is actually when you are taking into account the first alkyl halide, the halogen was like this, and the first methyl group was like this, is it not? Methyl group, and here the second one methyl group, and here we had the next methyl group. So this was the original compound. Okay, see, let us look into the retention product. So the same structure we have obtained here also. We have obtained the same structure, that is the OH group is in the same position as that of the halogen. But you look into the inversion product, the OH group is placed in the position opposite to the halogen. So this is called as an inversion product. Okay, so here also the same sp3 hybridization we are having, and the structure will be a tetrahedral structure. Okay, so the geometry is tetrahedral. Okay, here also we will be having 50%. Okay, so now side. So this type of product is called as a racemic mixture. Okay, what's the name of the product? See, it's a mixture of two products, right? So it is called as racemic mixture. Understood, students? See, next we should know the factors affecting the SN1 reaction mechanism. Actually, the important factors affecting this SN1 mechanism are leaving group ability. See, what I mean by leaving group ability? See, let us check. See, there are different types of halogens, right? Iodine, bromine, chlorine, fluorine. Okay, see, among these halogens, this iodide, that is iodide ion, has the larger size. Okay, so it has, iodide has the larger size, right? Larger size, so it can easily accommodate the negative charge, so thus it behaves a best leaving group when compared to other halogens. So the leaving group plays a vital role. See, if the group leaves easily, then the mechanism will take place fast. Okay, faster, right? So that's why it's the iodine, it's the best leaving group. Next comes bromine, next comes chlorine, and next comes fluorine. So next point is solvent effect. Normally solvents with high ionizing power helps SN1 mechanism. Okay, that's why we are making use of polar protic solvents. Okay, polar protic solvents. Next comes the stability of the carbocation. So greater the stability of the carbocation, more easily it is formed and faster will be the reaction rate. So if the carbocation is formed very easily, then the reaction will be taking place very fast. Okay, so it depends. The stability of the carbocation also plays a vital role. So when you are taking into account, the tertiary carbocation will be formed fast. Next comes the secondary carbocation, and next will be the primary carbocations. Okay, this is the reason why the tertiary alkyl halides will be undergoing the reaction fast. Okay, tertiary alkyl halides. Next comes the secondary alkyl halides, and next comes the primary alkyl halides. Fine, students, you might have understood SN1 reaction mechanism clearly. Suppose if you are having any doubts, please register your queries in the comment section. I will be very pleased to answer your queries. Thanks for watching.